Welcome to lesson 5.3 on dividing polynomials. Your objective is to divide polynomials using long division and synthetic division. So to simplify by dividing, whenever we have a monomial that we're dividing by, so meaning that there's not two terms, but there's just one term, then we can just break these up into all separate stacks, if you would casually call it that. Okay, so I have one stack and a second stack, and so really what I'm doing is I'm saying that if this sum is divided by 3a, then both parts are divided by 3a, and we can take the sum of them separately. So that's what I'm doing. And in this way, I can get these each as reduced as possible separately. That's 6a squared, because 18 divided by 3 is 6, and a to the third divided by an a, one of these a's and one of those a's cancels, and we're left with a squared. In other words, the exponents subtract. 3 minus 1 is 2. And 30 divided by 3 is 10, and a for 2 minus 1 is just 1. Alright, so that would be a reduced form of the original. Okay, so take this and break it up into two separate stacks. 24mn to the 6 divided by 4m squared n to the third minus the value 40m squared n to the third all over 4m squared n to the third. Okay, divide it separately. That is 6 n to the third over m, because 6 times 4 gets you 24. And over here, 1 minus 2 is negative 1, so it sinks, it goes under the vinculum in the denominator. And 6 minus 3 is 3. Minus 40 divided by 4 is 10. M squared divided by m squared completely goes away. N to the third divided by n to the third also completely goes away. So we're left with 6n to the third over m minus 10. I'll just write it a little bit more clear. Okay, number 3. We need 3 separate fractions. So 60a squared b to the third all over 12ab squared minus 48b squared over 12ab squared plus 84a to the fifth b squared all over 12ab squared. Okay, and then divide them all separately. 60 divided by 12 is 5. 2 minus 1 is a to the first. 3 minus 2 is b to the first. Then 48 divided by 12 is 4. B squared divided by b squared divides evenly, but I still have an a in the denominator. And then plus, and 84 divided by 12. I'm still in scientific mode, is just 7. And then 5 minus 1 is a to the fourth, and 2 by 2 goes away. So that would be the answer to that one. So that's how we divide by a monomial. We write it as 2 or 3 separate fractions, and then reduce each of them as much as possible. Okay, now let's divide by a binomial. So I want to divide using long division, and in this case, I'm going to use this really complicated process. And if you remember long division of just basic numbers, then this is kind of that, just gone to a larger scale. So we copy everything down. Okay, one thing I'm verifying is that if this polynomial skips any possible placeholders, like here it has the third power, then it follows it with the second, first, and no power. That's wonderful. Every possible power after the first one is here. If a power was missing, then I would need to put a 0 placeholder, because numbers in this process will develop that they need to go in that column and combine with other like terms in that column, and so I need a column for all those terms that are going to start showing up. Okay, First question is looking at these left two values. How many times does 2x go into 4x to the third? Or 2x times what would get you 4x to the third? Or 4x to the third divided by 2x gets you what? Okay, the way I like thinking of it is 2 times what gets me 4? That's a 2. 2 times 2 gets me 4. What times x is going to get me x to the third? And place it right here next to your 2. So what times x gets you x to the third? We need x squared more. X squared times x will get me x to the third. Great. You're done with that process. Take this now and distribute it to both those terms. Even though we haven't dealt with this one yet, this is the time for us to deal with it. We're going to multiply to it, okay? Not that much dealing with at all. 2 times 2 gets me 4. X squared times x gets me x to the third. They match. That's perfect. Distribute to the 1. It does not have to match the next term. 2x squared times 1 is 2x squared. Whatever it turns out to be is fine. Okay, draw a line beneath these two new terms and change both their signs. We're distributing a negative sign to them. Now work vertically and do the subtractions. So 4x to the third minus 4x to the third goes away. Negative 2x squared minus another 2x squared is negative 4x squared. Last step, bring down negative 6x. Now, do the process over. Look at these left two most terms and try to figure out what times 2x is going to get you negative 4x squared. So, and we start building that answer up at the top. What times 2 gets you negative 4? Negative 2. Negative 2 times 2 gets you negative 4. And what times x is going to become x squared? That would be x. X times x gets you x squared. So follow those distribution arrows and distribute to both terms. Negative 2x times 2x is negative 4x squared. Great, it matches. Negative 2x times 1 is negative 2x. It's fine. Go ahead and draw a line, switch both signs, and add vertically. Negative 4x squared plus 4x squared goes away. Perfect. Negative 6x plus 2x is negative 4x. Bring down the 1. Did any of the steps seem familiar? Okay, we're working first with familiarity, then we'll work for memorization. Okay, so what was the first step? We try to look at these left two terms and match them up. How does a 2x become a negative 4x? 2 becomes a negative 4 by multiplication of negative 2. And do we need any variable to multiply to x to get it to be an x? No, it's already got enough x there. X to the first, this is x to the first, so we don't need any more variable up here. Distribute, negative 2 times 2 is negative 4x, negative 2 times 1 is negative 2. Draw a line. What do we do next? Switch both signs. What do we do next? Add vertically. Negative 4x plus 4x goes away. 1 plus 2 is 3. Now how we do that 3, what we do with that 3, is because it's a positive 3, we're going to show plus, and we're going to continue the polynomial. 3 over and 2x plus 1 is what it's over. And that's because we still have 3 left from the original polynomial. Everything else was able to divide evenly except for this 3. And that 3 is what's left over here in this part, being divided by 2x plus 1 still. So 3 divided by 2x plus 1. All those parts divided by 2x plus 1 evenly, and got you this, except this remaining 3. Okay, let's try this again. But you say, this is a multiplication problem. But remember, now this is super nerdy, remember what we learned about negative 1 exponents? That really means sink me. Okay, so that wants to be sunk, so it wants to be under the vinculum, so it's really a problem that says this. Okay? So really, it's a division problem. Isn't that so nerdy? Okay, so they made a division problem. So let's go ahead and divide also by 2x plus 1, just like the previous problem. Well, that's kind of repetitive, but we'll do it. 2x plus 1 goes out in front. Recognize that you start with a fourth power and make sure that you have every term here that should be here after the fourth power. 4, 2. we're missing an x third term. So when I write these down, plus 0x to the third, I must make a column for it because I'm going to start having x to the third terms developing, and I want a column to put them in so that I'm combining like terms only. Minus 4x squared plus x minus 4. Okay, now try to match these up. What times 2 gets you 8? 4 times 2 gets you 8. What times x is going to get you x to the fourth? X to the third. Okay, let's write a little smaller this round. 4x to the third times 2 is 8x to the fourth. 4 times 1 is 4x to the third. See how we got something that's an x to the third? We wouldn't want it to be in the x squared column because silly us, we just get so used to a process, we might start to add it to that. And anyway, we're going to get x squared terms developing that are true x squared terms, and we would like them in that column. So we want to make sure these x to the third terms go in as their own column so that x squared terms can go in that column. Okay, so there we go. We got an x to the third. Go ahead and draw the line. What happens next? Slash both signs, like Walmart slashes prices, and 8x to the fourth minus 8x to the fourth goes away. 0 minus 4 is negative 4x to the third. Bring down minus 4x squared. Match them up. 2 times what gets you negative 4? Negative 2. And x compared to x to the third, it needs x squared. Distribute. Negative 2x squared times 2 is negative 4x to the third. Negative 2x squared times 1 is negative 2x squared. Draw a line. Slash both signs. Add them up. Negative 4x squared plus 2x squared is negative 2x squared plus x. Match them up. How do you get a 2 to become a negative 2? Times it by negative 1. X to become an x squared, times it by x, and distribute. Negative x times 2 is negative 2x squared. Negative x times 1 is negative x. Draw a line. Slash both signs. Okay, x and x gives you 2x. Bring down a minus 4. Okay, 2x needs to match to a 2x. It already does. So multiply by a 1. 1 times 2x is 2x. 1 times 1 is 1. Draw a line. Slash both signs. 2x minus 2x goes away. Negative 4 minus 1 is negative 5. All right, you got a remainder of negative 5. Do you remember how to write the remainder? Okay, take minus this time because it's a negative 5. 5 over 2x plus 1. All right, and that is your polynomial answer. Okay, so let's go on to number 7. Divide 4g squared minus 9 by this binomial here. So, 2g plus 3 divided by 4g squared plus 0g minus 9. Okay, we need that 0g column just like we needed this 0x to the third column because we're going to have all these x to the thirds developing and separately all those x squareds developing, and we want our x to the thirds to combine only with x to the thirds, and we want our x squareds to be combining with x to the seconds, and we want our own space for them because they're going to go side by side, so we really, really need that 0 placeholder. Okay, anyway, match these up. Looks like we need to multiply by 2g. 2g times 2g is 4g squared. 2g times 3 is 6g. Slash the signs. 0 minus 6 is negative 6 minus 9. Okay, 2 times negative 3 gets you negative 6g. Negative 3 times 3 gets you negative 9. Slash both signs and you have no remainder. So 2g minus 3 is the final answer. Okay, I'm going to skip to number 9 down below using synthetic division. Synthetic division says to take this polynomial and to divide by x minus 4. Now, in the case of the entire side of the worksheet here, or notes packet here, I have all x coefficients of 1s. When you have an x coefficient of 1, you have the advantage of being able to use synthetic division. It's a lot faster. What I'd like to do is to put in the box off to the side just the opposite of the sign of the value over here. This takes the place of the subtraction step, or switching the signs that we did in the long division. Then over here, I would like to list out the coefficients. So 5, 1, -4, 1. Being careful that if there's a missing term that I'm leaving a 0 placeholder for that term. But since 3 follows by 2, 1, none, then I've got all the terms after the first one, so there's no missing terms in this grouping. Okay, so put out just the coefficients, put a plus sign here on this line, and do this step just once. Bring the 5 all the way down under the line. 5 comes around and times to 4. 5 times 4 is 20, and that's pretty much almost the whole process. 20 plus 1 is 21, there you go. That's the whole process all the way around and around. 21 goes back around this arrow, multiplies to 4. 21 times 4 is 84. So 84 minus 4 is 80. 80 times 4 is 320. Add it to 1, and you get 321 for the remainder. Now, here's how you write your final answer then. We're going to go down 1 power. Okay, so that means if this is written, and the original polynomial starts with an x to the third, we're going to want to start our answer with x to the second. And that's because we essentially divided an x minus 4. So if you think kind of more of the stack version of dividing, we can divide each of these by an x. And in that way, one x is lost from each of them by cancellation. Okay, so that's kind of a rough idea of what's happening there. So our new coefficient that we start with is a 5, and I want to go down 1 power from the first term. So x to the second. Then keep going through here to the next coefficient, and then go to the term before and reduce by a power, x to the first. Go here to get your next coefficient. Since it's a positive 80, we do plus 80. Now I have a remainder, plus 321 over x minus 4. Okay? So just as easily as we lost our variables and we got just coefficients, we got an answer with just coefficients. We need to get back our variables. Go down a power, and then each term go 1 power less. Okay? Your last answer is always your remainder. All right, let's go to the next one. X minus 2, put a positive 2 in the box. Write out your coefficients. Be careful. Whatever your first power is, make sure you double check that all the powers after are present. So after 3 comes 2, 1, none. Good. All the next groupings of powers are there. All the next values of powers are there. Go ahead and next to your box, lay out your coefficients. I always leave a little extra space just so that I can clearly identify what the coefficients are. First one comes all the way down. Then, what did we do? We multiplied. 3 times 2 is 6. Then we added. -7 plus 6 is -1. -1 times 2 is -2. And 9 minus 2 is 7. 7 times 2 is 14. 14 and -14 is 0. No remainder. How did we write our answer? Go to the third power, go down 1 power, and go here for your coefficients though. 3x squared minus 1x plus 7. No remainder, so that's it. Okay, let's do one more problem. We're going to do number 12. Over here, put the opposite sign in the box. Put out your coefficients, but look at this. We have a whole slew of coefficients missing. So we have a 5th power. We don't have an x to the 4th. We have a 3rd power. We don't have an x to the 2nd. We do have an x, and we do have a constant. So let's go ahead and make sure that we follow this idea of term to term here. So I have 1 x to the 5th, 0 x to the 4th, negative 7x to the third, 0x squared, 1x, and 1 to finish it off. Okay. Bring the first term down. 1 times negative 3 is negative 3. That gives me negative 3. That gets me 9. That gets me 2. That gets me negative 6. Negative 6. Positive 18. And 1 is 19. Times 3 is negative 57, because 20 times 3 is 60. And that's negative 56. That's my remainder. Go ahead and go 1 power less. From the 5th power, that's x to the 4th power, or 1x to the 4th power, minus 3, go 1 power less, x to the 3rd, plus 2x squared, minus 6x plus 19, minus 56 over x plus 3. Thanks for joining.